All right, so I think I'm recording. Let's take a look at these two problems, 15 and 16. What we're doing in this group of problems is matching an equation to its graph. And we're actually using our knowledge of function transformations that we learned in a previous skill packet to do it. So in a previous video, I illustrated how the equation for number 10 matches to the graph of A. And now what we're doing is transformations on this graph of A. So when we look at 15 and 16, we have here transformations on the domain, 16 times x. Well, when you have transformations on the domain, it's a little bit bizarre in the behavior, because even though it says 16 times x, we actually divide by 16. So the transformation of the graph of A, we're going to horizontally shrink it by a factor of 1/16. So it's a horizontal shrink by a factor of 1/16. Even though it says to multiply the x-coordinate, we're actually going to divide the x-coordinate. So let's look and see if we have our 2 points that are easy to read from the parent function, if we can figure out and if they'll be easy to read from this transformed on this transformation. So 1, 0 transforms to 1/16, comma 0. So real close to the origin, real close to 0, 0. Now, what about 4, comma 1? If I divide by 16, 4 over 16 is 1/4. So those points are not going to be quite as easy to read, but remember, every point got shrunk. So we're looking, and it's being shrunk towards this y-axis. So B it looks to be a reflection upon A, so I'm not going to choose the graph of B. The graph of C looks like it got lifted up. This point 1, 0 got lifted up to 2, 0. I'm not going to pick that graph. Now here, no, it can't be this one. This looks to be like a vertical stretch. This is a reflection. This is a reflection. Now here, this looks like it could be a horizontal change, but a horizontal stretch rather than a horizontal shrink. So we're not looking for that one. So okay, on my first go around, I didn't see. Let's come back. Oh, look, when I eliminated C, you know, I was quick to eliminate that because I focused my attention. I don't know what I said. Maybe I said a shift up or down. This looks to be like it has been shrunk towards the y-axis. That this point that was at 1, 0 is now real close to the origin. And this point that was at 4, comma 1 has now been horizontally shrunk to where this point right here is 1/4, comma 0. So this graph that looked like this has been shrunk. The horizontal shrinks, the vertical shrinks, the horizontal stretches and vertical stretches. Maybe you should learn from what I just did and slow down a little bit, because if you go too quickly, you might miss it. They're a little bit harder to see than the rigid transformations because, see, the graph changes shape. So it's a little bit harder to see. All right, let's take a look and see if we can figure out easier than what we did on 15, if we can figure out what 16 is. All right, so instead of dividing by 4, we're actually going to multiply by 4. So our description, what we're looking for is the graph of A, but it has been stretched. And it's a horizontal stretch. And it's by a factor of 4. So this 1, 0 has been transformed to 4, 0, and 4, 1 is transformed to 16, 1, which is off the graph. So we're not going to, that point may not really be all that helpful. Although that we know that it's not going to have a lot of height. If by 16 units to the right you've only gone up one, the graph is going to hug the x-axis, so that might help us. So it's not the graph of A. You know, we did transform, we did stretch the graph of A, so it's not the graph of A. B was a reflection. We said C was a horizontal shrink, not a horizontal stretch. Now D, I think that D is going to be like a vertical stretch. E is a reflection. F is a reflection. Now this G has possibility because it's passing through the point 4, 0, and even though at 10, it's less than 1. So if I move to the right 16, and look how slow it's gradually, G looks to be the candidate so far that I'm going to pick. And yeah, H is a shift to the right 4 units. J was a shift to the left. So this has to be the graph of G. Okay, so our stretches and our shrinks slow down a little bit. You can see that I almost skipped over it in number 15. Whether it's a horizontal stretch or shrink or a vertical stretch or shrink, slow down and make sure that you reason through. A lot of times you can get these by the process of elimination by knowing that it's not the other graphs. All right, so I hope that helps, and I'll talk to you later. Bye.